Hello everyone, my name is Suhani Nalwar. Today I'll be presenting on model selection, the art of choosing the right tool. This topic is crucial in the field of machine learning as choosing the correct model often determines the success or a failure of a project. So let's get started. What is model selection? Model selection is the process of choosing the most suitable model from a set of candidates for a particular task. It's not just about picking the most complex or accurate one. It's about finding a balance between performance and simplicity. The ultimate goal is generalization, building a model that performs well on unseen data, not just the training data. We must also avoid common pitfalls like overfitting, where a model learns too much from a training data and fails on new data, and underfitting, where it doesn't learn enough and performs poorly. Why is model selection important? Let's discuss why this process matters. Overfitting causes models to memorize training data and fail on new inputs, while underfitting means the model is too simplistic to capture patterns. Selecting the right model helps strike a balance, ensuring we capture patterns without noise. Ultimately, good model selection maximizes predictive power, which is the goal in most real-world applications. Key criteria for model selection. To make the right model choice, we need to consider four key criteria. First is accuracy. How well the model performs, often measured using metrics like RMSE or AUC. Complexity. Simple models are easier to generalize, while complex ones may overfit. Interpretability. Can the model's predictions be understood and explained? Computational cost. We also consider how much time and resources it takes to train and run the model. These criteria guides us in balancing performance with practically. Now let's look at the most commonly used techniques. Cross-validation helps estimate model performance reliably by testing on different subsets. Data splitting divides the dataset into training, validation, and test sets to tune and evaluate the model. Regularization adds penalties to discourage overly complex models using L1 and L2 norms. Information criteria such as AIC and BIC, which assesses both model and complexity. These techniques helps us make informed, data-driven decisions during model selections. Cross-validation deserves special attention. There are several types. K-fold cross-validation. The dataset is split into K part. Each part is used as test set while the rest serve as training data. Leave one out. In this, an extreme version of K-fold where only one data point is left out at a time. This is true but computationally expensive. Stratified cross-validation. Here, especially for classification tasks, this maintains the proportion of classes in each fold. For example, using 10-fold cross-validation can reduce overfitting by 15%, a significant performance boost in practice. Implications of good model selection. When model selection is done right, it leads to improved accuracy. Your model is better at making predictions. Reduce overfitting means it performs well on both training and new data. Better insights means a well-chosen model is easier to interpret and trust. Efficient resource use. You don't waste time and computation on complex models where simpler ones work. This is how critical model selection is beyond just numbers. It impacts interpretability and efficiency too. Case studies. Let's look at the real world examples. Medical diagnosis means in medical diagnosis, selecting the best features and models helps predict disease more accurately. Second, fraud detection. Anomaly detection models must be finely tuned and to minimize false alarms and catch real frauds. Third, recommendation system. Choosing the right algorithms ensures better user experiences by accurately predicting preference. Each domain benefits greatly from careful model selection tailored to its needs. To conclude, model selection is not just a technical step. It's a critical decision making process that affects the success of any machine learning project. Choosing the right model ensures performance, reliability, and usability. Always remember, it's not about choosing the most complex model, it's about the choosing right one. Thank you so much for your attention. I hope this presentation has given you valuable insights into the model selection. Thank you.